which is something that I have kind of mentioned earlier, but we just want to elaborate a little bit more on, which is that, as I said, each different priority rule, each sequencing rule gives us a different schedule. So how do I decide which schedule is best? Well, as we already said, that depends on the criteria that we use. Among those criteria are the ones we have looked at earlier, for instance, the average flow time, the average hours early, or the average hours past due. There could be some other criteria, such as like the proportion of jobs that have been completed on time, proportion of jobs that have been completed past the due date. There are a lot of different combinations, but it's also, the problem itself is actually more complex than that, because remember that we're doing this now for only one product, basically, or for one type of job. Whereas in a typical manufacturing process, as we looked at the diagram, we could have actually a number of different jobs using similar or using the same workstations. That makes the problem even more complex. Okay, that's what it says here. It makes the problem more complex because in a lot of cases, the output from one station becomes the input for another. So if we actually consider the scheduling of the jobs for the entire system, then I will have to decide about the scheduling of the jobs for the specific machines or workstations. That's the complexity. That means here I might actually be looking at one job, okay, from beginning to end. But in the end, I have to actually set up specific schedules for each machine or for each work center. And that makes the problem much, much more complex. So how do we deal with this level of complexity? Well, as here it indicates, simulation could be a very useful technique or a useful tool in helping us determine which priority rule works best in certain situations. And therefore, the way it works is that you model the process, and then you can change the priority rules at various operations and then measure the impact on performance and check. Okay, there are a number of different simulation softwares for scheduling jobs. I checked. Most of them are paid. That means you actually need to pay for them. But there are, I think, some versions where you can get a demo. Okay, you can maybe try to download one of these demos. For instance, here they have like the SimQuick that goes with this particular textbook, the operations management by Malhotra and so on. But the point that I wanted to make is that the problem is complex, and simulation helps us in dealing with that problem, helps us in identifying them. We can also, a simpler version of that is what I did earlier. Okay, if I use for instance, something like Excel. Okay, you see, I've already have like two EDD schedule, SPT schedule. I can actually keep changing here the processing times or whatever other things. I can add one, model for each different priority rule and look at the performance criteria values, and then that will help me make a decision in a more efficient manner. Okay, so simulations, once again, we talked about simulations before, but simulations, once again, they can be very helpful in the context of scheduling jobs when I have multiple workstations, because the problem is more complex and it cannot be, in most cases, modeled precisely in a complete manner. So the alternative is simulations. So that's the point that I wanted to make before we look at the practice exercise. Now the exercise is this one. This is week 9. Yeah, so this is the question that we have. Again, it's very similar to the one that you have seen in the lecture, with obviously different values and so on. Develop separate schedules using the shortest processing time and the earliest due date rules. Compare the two schedules on the basis of two things: average flow time and percentage of past due jobs. Now, average flow time, we have seen that. We have seen an example of average flow time, which is simply the average of the flow times of all the jobs, sum divided by the number of the jobs. How about the percentage of past due jobs? Well, it's just the a ratio of how many jobs are past due to the total number of jobs. So I have 5 jobs here. If, for instance, we find that 2 of them are past due. Now, how do I know that they are past due? We know by looking at the hours past due or days past due. Like, for instance, in this example here, the one we did earlier, we have past due 1, 2, 3 jobs. Why? Because they have more than 0 hours past due. So these jobs are past due. There are 3 of them, 1, 2, 3. What will be therefore the percentage of past due jobs in this example? Well, it's going to be the number of jobs that are past due, which is 3, divided by the total number of jobs, which is 1, 2, 3, 4, 5. Okay, so it's going to be 0.6. If we make it as a percentage, 60%. All right. How about in our previous, in the other schedule, in the SPT schedule, it's also 3. 1, 2, 3 of the jobs are past due. So it's also going to be 3 jobs divided by a total of 5. So we're going to have, again, 60% of the jobs are past due. All right. So that's what the percentage of past due jobs means. So back to the question. All right. Based on that, compare the 2 schedules and essentially say which schedule is better according to each criteria. Now, the best way to do this is really to do the following. Okay, I'm going to copy the table. I'm going to make this actually portrait. It's better. Okay, I'm going to copy the table and then fill it with the information that we need from this example. Okay, so here we're talking about engines, so same thing except that now it's in days, so we're gonna change these in days. Okay, day. Okay, this is day, so we're gonna copy it. It's in days. All right, so this one would be days early and days past due. All right, the other thing is starting with the, okay, the first one, they said do the shortest path or shortest processing time. So the SPT schedule. Okay. The engine sequence. We're talking about engines as well here. Okay. Processing times and so on and so forth. So for the first schedule, we're going to use the shortest processing time. These are the processing times. So this is what I need to focus on. Okay. What is the first of these that needs to be worked on? The one that has the shortest processing time is
job 4.
Is job 4, correct? So it's therefore this one. So the first one is job 4. And let's fill out the remaining information. So time since order arrived is 1 day. Processing time is 1 day. And promised date is 20, which is the scheduled time. That's therefore our first job. The second one is
job 5.
Job 5, correct. It's the second one. So the shortest one, then 3, which is the 75 horsepower. Okay, the values 15, 3, and 10. So 15, 3. This is data. The following job is, so we have 1, 3. The next one is this one. So it's the job, the horsepower Johnson, 7 horsepower Johnson. and 6, 4, and 15. Okay. Then we have then what do we have? The next one will be, so 1, 3, 4, the next one is 5, so the horsepower, whatever, and the values for that are, we have 4, 5, and 8. And the last job in the sequence is the one with the highest processing time, so it's the Mercury horsepower, the Mercury engine. Okay, and the values for this are 8, 10, and 12. All right, so let's start with the beginning. What is the beginning work day?
0.
It's always, for the first one, it always starts from 0, correct? All right. It takes 1 day to process, so the finish time will be the beginning plus the processing, which is 1 day. Is this clear? The finish time is the beginning work plus the processing time. The flow time is the day since order arrived, which is 1, plus the finish time, which is 1, and therefore the flow time is 2. So 1 plus finish time equals 2. For the actual pickup, we said it's the maximum of the finish time, which is 1, and the scheduled pickup time, which is 20. What is the maximum of the two values? What is the maximum?
20.
20, the larger of the two values, correct. For the days early, we take the actual pickup, so 20, minus the finish time, so 1, and that gives us 19. So intuitively what that means, it means that we have finished this job 19 days before it is due, before the customer picked it up. If it has 19 days early, so even without calculation, what do I know about the days past due? If it was early, so it cannot be late, it must be 0. All right, and this can actually tell you if you have a mistake or not. That means if I calculate the days early and it's a positive number, and I calculate the past due and it's a positive number, then I know I have made a mistake somewhere. If it's early, it cannot be late. If this number is non-zero, then this one must be 0. And the opposite. If this one is non-zero, then this one must be 0. Okay? In simple words, it cannot be late if it is early. And indeed, it is actually actual minus scheduled, 20 minus 20, which is 0. This is for the first job. Is this clear? Because if you know how to do this for one job, then you know how to do it for all of them, Is every value in this table clear?
Yes, doctor.
Okay, great. So we're going to continue now. Then, for the second job, the start time, the begin time, is the finish of the previous one. Okay. And just to help you out, I'm going to actually write here, the start time is the finish of the previous one. So it's 1. We finish the previous job, we start the next job. So here is gonna be the beginning time plus the processing time, which is 4. So 1 plus 3 is 4. For the flow time, okay, it's the days since the order arrived, how long we have received the order, plus the finish time, which gives us flow time of 19 days. So what does this mean? It means that the job, this engine, has been or will stay in the system for a total of 19 days, 15 days since we received the order. It was already waiting, and then day 4 it was completed, 1 day waiting and 3 days processing, and so on. So now the maximum of the finish and the promised time, which is the due date, 19. Is this job early or late? Before calculating the values, just by looking at this.
Late.
Is this? It's definitely late. We promised it day 10, we finished it day 19, so it's definitely late. So here it must be 0. The days early must be 0. Okay, and indeed, it must be 0. It's actually, the actual minus the finish, which is 0. All right. So I'm saying just by intuitively, I know that it must be 0. Even if I don't calculate it, it has to be 0. The calculation should only confirm what I know. For the days past due, I take the actual minus the promised. So we have 9 days late. That's what it means. Okay, so this job will be 9 days late. And we continue like that. So for the beginning of the third job, it will be on which day? Anyone? So the third job, when will we begin the third job? Which day?
Day 4.
Day 4, correct. We finished the previous one at day 4, so we start this job. Therefore, the finish time will be 4 plus 4, which is 8. The flow time is the days since the order arrived plus the finish time, so 14. Finish time, the maximum of the finish time and the promised time. Okay. So before I calculate, is this job early or late? Even before I calculate the values. It was scheduled day 15, we finished it on day 14, so therefore it is late or early?
Early.
Early, correct, because we finished it before it was promised. So 15 minus 14, it's 1 day early. And therefore, what should we have in the past due date? In the days past due, it must be 0. It has to be. And indeed it is. It's 15 minus 15. It's the actual minus the promised. And go on to job number 4. So number 4 we have, it starts on day 8. It will be finished on day 13, 8 plus 5. Okay. The flow time will be 4 days since we received the order plus 13. Day 13 is the finish, so 17. The maximum of 17 and 8, which is 17. Is this job late or early? It's definitely
Late.
late. It's definitely late. And that's why the days early will definitely be 0. Whereas the days late is 9. It's 9 days late. 17 minus the schedule of 8. Finally, for the last job, it's day 13 is the starting. 13 and it takes 10 days, so we'll finish it on day 23. it will be in the system a total of 8 plus 23, so 31 days. 8 plus 23, so 31 days. It was promised day 12, so therefore it's definitely late. Okay, so this is the maximum of 23 and 12, which is 23. So it's definitely late. It is therefore 23 minus 23, which is 0. And 23 minus 12, which is 11. It's 11 days late. Okay, now this is as far as the table goes. For the average flow time and the percentage of past due jobs. So, average flow time is equal to, I sum the flow times, divide by the number of jobs. So it's 2 plus 19 plus 14 plus 17 plus 31 divided by 5. 5 is obviously the number of jobs. They have 1, 2, 3, 4, 5 jobs. And what do we get if you have already done this?
16.2.
16.2. And it's 16.2 what? What's the unit?
Days.
Days. Talking about days. Okay, correct. So the average flow time is 16.2 days, and now the percentage, that's what it says the percentage of past due jobs. Well, how many jobs are past due?
3
I look at
jobs.
the, how many jobs past due? The ones that have non-zero past due days. So past due, there's 1, 2, 3. There are 3 past due jobs. How do I know? Well, because it has, this one is 9 days past due. This is 9 days past due. This is 11. So it is 3 divided by, why 3? Because I have 3 jobs. 1, 2, 3. Divided by the total of number of jobs, which is 5. Multiplied by 100% to have it as a percentage. And this gives us 60%. That's it. This is for the first sequencing rule. So this is for the SPT schedule. Are there any questions up to this point? Is this clear? Is this clear? All right. We're going to do the same thing now with the EDD schedule, earliest due date schedule. So just to, make use of the all right. Now, the earliest due date. So we need to sort it by this one, by the scheduled customer pickup. Instead of doing this manually, I'm going to do this using, the word that I have here. Okay, I'm going to sort it on column number 1, 2, 3, 4, 5, 6, 7. Column number 7. And there, instead of rewriting everything, I'm gonna sort it with the scheduled customer pickup time. Why? because that's what the rule says. The ones that have the smallest scheduled pickup time goes first. Okay, so therefore this is the ordering of the jobs. This is the schedule of the jobs. And we're gonna fill it now with the values. As we said, we start work at day 0, and therefore for the first job it's gonna be finished on day 5. The flow time will be 4 plus 5, which is 9. The actual pickup time will be the maximum of the finish time, which is 5, and the scheduled time, which is 8, so therefore 8. So is this job early or late? What do you think?
Late.
Well, it's due, it was promised on day 8 and we finished it on day 5. So is this late or early?
Okay, it's early.
It's actually 3 days early, correct. All right, so therefore it's definitely 0 past due, because it's early, it cannot be late. This must be 0. Second job, we can start it as soon as we finish job 1, so we're gonna start it on day 5, which means we'll finish it on day 8, 5 plus 3. For the flow time, it's been with us 15 days and 8 days to finish, so 23, 15 plus 8, 23. The actual time for pickup is the maximum of 23 and the promised pickup day, which is 10. And what do we get here? 23, obviously. So is this job early or late? Now, this is definitely late. It was promised on day 10. It was finished on day 23. We're actually 13 days late.
Doctor,
Yes.
why in the first job you take from flow time, no, from finish time and schedule customer, but for the second one you take from flow and scheduled?
For the flow time?
For the actual customer pickup, for the first one,
yeah.
yeah.
Mm-hmm.
For the first,
Oh, thank you very, very much. No, I made a mistake. You're right. This should be the finish time, not the flow time. 8. Correct. Thank you for pointing that out. No, it's definitely the finish time, not the flow time. Okay, it's very clearly. It's the finish time, not the flow time. So it's the finish time and the scheduled pickup time. Very good. And therefore, this is actually early, not late. Okay. So it's gonna be actual minus finish time 8. It's gonna be 2 days early, which means the past due days must definitely be 0. And it is. 10 minus 10 is definitely 0. Very, very good. Okay, so now for the third job, we're gonna start it as soon as we finish the second one. So therefore, we'll start on day 8. It takes 10 days to finish. 8 plus 10, so it's gonna be 18. For the flow time, 8, which is the days since the order arrived, and 18, which is the finish time, so 26. And therefore, the maximum of the finish time and the promised time, so this job is definitely late. We finished it on day 18. It was promised on day 12. Okay. And therefore, the early must definitely be 0 because it's late. Whereas for the past due, it's the actual minus the promised, so 18 minus 12 is 6 days. For the next job, it's gonna start on hour 18. It takes 4 hours, so it will be finished on hour 22. The flow time will be 6 plus 22, so 28. 6 plus 22, 28. This will be the maximum of 22 and 15, so this job is also late, 22. Okay, it's also late, and therefore if it is late then it cannot be early. So 22 minus 22 is definitely 0. How many days it's late? The actual 22 minus the promised 15, so it's actually 7 days late. 22 minus the scheduled time. For the last job, we started on day 22 because that's when we finished the previous one. 22 plus 1 processing, so day 23. 1 plus 23 flow time, so 24. Max of the maximum of 23 and the promised 20. So this job is also late. Therefore, the hours early, days early must be 0. And it is 23 minus 23 is 0. 23 minus 23. And for the past due, it's 3 days past due. 23 minus 20. So the average flow time, I'm going to take this flow times, okay? So 9 plus 23 plus 26 plus 28 plus 24 divided by 5. Okay, so this column here, that's what we need to consider. So 9, 23, 26, 28, 24, the sum divided by 5, that will give us the average flow time. What do we get?
22.
22 days. Percentage of past due jobs, the same thing. I look at how many jobs are past due. They are the jobs that have a positive number of past due days. Again, I have 3 of them. Okay. There are 3 jobs, a total of 5. So it's also 60%. Okay. So in comparing the 2 schedules, let's summarize now. All right, this is the summary that we have. So to answer our question, okay, both schedules, in terms of, okay, the question, what did the question say? The question says, compare the 2 schedules on the basis of average flow time and the percentage of past due date jobs. Okay. So first of all, in terms of the comparison based on the average flow time, which schedule is better? It's the schedule that has the smaller average flow time. So as you can see, the flow times, we have 16.2 and we